Now here's another problem dealing with expected value. A game is played by selecting one bill at random from a bag that contains 10 $1 bills, 5 $2 bills, 3 $5 bills, 1 $10 bill, and 1 $100 bill. The player gets to keep the selected bill. There's a $20 charge to play the game. What is the expected value? What does this value mean? We're going to evaluate this by setting up a chart as we have a number of different outcomes. So we're going to have a column for the outcome. We'll have a column for the gain or loss associated with that outcome. And we'll have a column for the probability of that outcome. So what can be our different outcomes? Well, we're going to be selecting one bill at random from a bag that contains different bills. So we could pick out the $1 bill. Now, what would be the value of that? Well, if we choose only $1 and we've paid $20 to play the game, then we have a loss of $19, and we'll use a negative sign to indicate that. What is the probability of choosing the $1 bill? Well, we have 10 $1 bills out of, and we have 10, 5, 3, 1, and 1. That's 20 bills altogether. So the probability is 10 out of 20. We could reduce this, but it's probably going to be better to keep the denominators the same for our probabilities as we move along in the problem. What could be another outcome? We could choose, instead of the $1 bill, perhaps we pick up the $2 bill. That would be a loss of $18 as we've paid 20 to play the game. The probability of choosing a $2 bill is going to be 5 out of the 20. Next, moving along, we could pick the $5 bill. That would be a loss of $15 overall. And there are 3 $5 bills, so that's going to be 3 out of 20 probability. We could pick the $10 bill out, and there's only one $10 bill, just make note of that. That would end up being a loss of $10, and we have 1 out of 20 probability. And we could pick out of here the $100 bill. That would end up being a gain of $80, and probability is going to be 1 out of 20. Now, to figure out the expected value, we're going to notice that we're going to have to take the value associated times the probability of each of these different outcomes. So we're going to end up setting up our expected value as follows. We're going to have E, expected value equals, and let's just run across our chart. So the first value, we're going to have the negative $19 multiplied times the probability of 10/20ths. We're going to add to that, along our second row, we have a value of negative $18, and that probability is 5/20ths. Continuing on in this fashion, go to the third row. We have negative $15 times 3/20ths. We're going to add to that, fourth row, negative $10 times 1/20th. And then finally, we're going to add to that the last row, which is $80 times 1/20th. Now, we're going to evaluate each of these, and just to review, in order to evaluate, we can multiply the number, negative 19, times the numerator, in this case 10, and then put that value over 20, as this is like over 1. The negative 19 can be thought of as negative 19 over 1. So we're going to have a negative 190/20ths plus, we're going to have a negative, and we're going to multiply 18 times 5, which would give us 90 over 20, plus we're going to have negative 15 times 3, that's negative 45 over 20, plus we're going to have negative 10 times 1, that's negative 10 over 20, plus, and then we have 80 times 1 over 20, and that's going to be 80 over 20. So we have 5 different fractions, all with the same denominators, so we can combine numerators, and that when we do so, we come up with a negative 255 over our common denominator of 20, and so we end up with our expected value equal to a minus 12.75. Now, what that's saying to us is that we have an expected value of a loss of $12.75. Now, what that means is over time, what you would expect is that you would get closer and closer to losing this much per play. So because we have a loss, this game is not considered fair, and in fact, you probably would want to avoid it.